Its mass is thought to be between 5 and 13 times that of Earth, and its radius is 2 to 3 times bigger. The planet takes 16 days to orbit its star. Since it is located closer to the star than the habitable zone's inner edge, conditions on the planet are too extreme for life to form or survive. TOI 700d, the third and farthest planet in the system, is in a better position. It orbits its star in 37.4 days and is near the inner edge of the habitable zone. While the exact mass of TOI 700d hasn't been figured out, it's believed to be between 1 to 3 times Earth's mass. The planet's radius is about 20 to 30% larger than Earth's. Scientists think TOI 700d is rocky, but they don't yet know its exact makeup. It gets 86% of the energy from its star that Earth gets from the Sun. If its atmosphere is like Earth's, the surface temperature is estimated to be about minus 4.3 degrees Celsius, 268.2 K. However, this could change depending on the planet's greenhouse effect or atmospheric conditions, which are not fully understood. The eccentricity, or the oval shape, of TOI 700d's orbit is thought to be small, around 1, meaning it stays relatively close to a circular path. However, there may still be times when the planet gets too close to its star, moving out of the habitable zone. Despite this, its year is shorter than ours, lasting only about a month. If life exists on TOI 700d, it could survive these extreme periods by going into a dormant state or moving to cooler areas. Though the data from the spectral analysis of TOI 700d isn't enough to confirm everything, there is a chance that liquid water exists on its surface. The greenhouse effect could also warm the planet to temperatures that might support life. Like the other planets in the system, TOI 700d is probably tidally locked to its star, meaning one side is always facing the star. This creates a big temperature difference between the sunny side and the shadowed side. If the atmosphere is thick enough, it could help balance out these extreme temperatures, but this could also lead to powerful hurricanes. Meanwhile, the TESS mission, which is designed to look for exoplanets, has completed its main goals but keeps collecting data. It will continue taking pictures of the sky, including the challenging region of the Milky Way plain. So far, TESS has discovered over 2,100 exoplanet candidates, with 66 of them already confirmed. Additionally, the mission has recorded 6 supernova flares, found 3 exocomets, and taken many photos of smaller objects in our solar system, which, while not part of the main mission, are still useful for scientific research. Just before Halloween in 2020, NASA released a list of some of the scariest worlds in the universe. Among these strange places were 6 exoplanets, each with environments so extreme that no living creature could survive there. Even getting close to these planets could be deadly. One of the most frightening objects on this list is a black gas giant called TRES 2b. This planet orbits a star named TRES 2, which is a yellow dwarf located 7 to 18 light-years away from Earth. This gas giant has some special features that make it one of the darkest planets ever discovered. Its surface is made of materials that absorb over 99% of the light that hits it, giving it a completely black appearance. Scientists are still confused about why the surface absorbs light in this way. Unusual chemical reactions may be happening on the planet's surface, reactions we've never seen before. This strange phenomenon makes TRES 2b the darkest exoplanet known to us. TRES 2b was first discovered on August 21, 2006, and more details about its features were found in the years following. The planet's mass is 1.2 times that of Jupiter, and its radius is 1.27 times bigger. The atmosphere is extremely hot, with temperatures reaching up to 1,000 degrees Celsius. This heat causes the planet to glow with a faint red color, similar to the soft glow of burning coals. Even though TRES 2b has a frightening appearance, It's not the most dangerous place in the universe. Other objects in space are even more terrifying, hiding out there in the vastness of the cosmos. Another fascinating exoplanet, designated 55 Cancri E, is located in the system of a star that is similar to our Sun, named 55 Cancri A. This celestial object was first discovered on August 30th, 2004, using the Doppler spectroscopy method. The planet's mass is about 8 times that of Earth, and its radius is nearly 1.875 times larger than Earth's. 55 Cancri E is tidally locked, meaning one side of the planet always faces its parent star, while the other side remains in permanent darkness. As a result, the side that is exposed to the star is extremely hot, reaching temperatures up to 2,400 degrees Celsius, while the dark side is slightly cooler at 1,300 degrees Celsius. These extreme temperatures are caused by the planet's proximity to its star, located only 0.183 astronomical units away, much closer than Earth is to the Sun. The planet is likely to have volcanic activity, which creates dust clouds that trap heat, preventing it from escaping into space. These dust clouds act as a blanket, keeping the surface of the planet incredibly warm. The planet's orbital period is just under 18 hours, which means it completes one full orbit around its star in less than a day on Earth. As for its atmosphere, 55 Cancri E contains helium, hydrogen, and large amounts of carbon. This carbon could potentially form thick layers of graphite and diamonds deep within the planet's interior, making it a truly unique and exotic world. 55. Cancri E is not the only planet in its system. 4 other planets are orbiting its host star, and their environments are much more hospitable compared to 55 Cancri E. This is what sets the 55 Cancri A system apart from another intriguing exoplanet system known as Poltergeist, or PSR 1257+112c. This planet orbits a pulsar, a highly magnetized rotating neutron star. Located just 0.36 astronomical units from its pulsar, the Poltergeist wouldn't have survived the supernova explosion that preceded the formation of the pulsar. It is believed that Poltergeist formed from the debris left behind by this explosion. Another theory suggests that the pulsar itself was born from the collision of 2 white dwarf stars, which doesn't necessarily involve a massive explosion. However, since Poltergeist is the first of its kind to be discovered, scientists are still uncertain about its exact origin. The star system we're talking about is located 2,300 light-years away from Earth. The object at the center of this system is about 4 times the mass of our planet, and it takes about 66 days to complete one full orbit. One of the most impressive features of this system is the huge radiation released by the pulsar at its center. This radiation is so strong that any spacecraft trying to get too close would be destroyed by the force. Even with all these extreme traits, this exoplanet isn't actually the most dangerous one we've found. If a space object gets too close to this system, it could be torn apart, but this is nothing compared to what would happen near a different star in the same area. Planet Kepler 70b, which is the hottest exoplanet we know of, takes danger to a whole new level. It orbits around a star called Kepler 70, a subdwarf star that's much hotter than our Sun, with a surface temperature reaching 6,800 degrees Celsius. Kepler 70b itself has only about 44% of Earth's mass and a radius of just 76% of Earth's size. Its orbit is incredibly fast, completing one revolution every 345 minutes, meaning a single day on Kepler 70b lasts less than 6 hours. An interesting feature of this exoplanet is that it regularly passes very close to another object in the system, Kepler 70c, at a distance of only 240,000 kilometers. This is the closest encounter between 2 planets that we've ever recorded. The extreme heat on Kepler 70b may be due to the idea that it could have once been a part of its parent star, but scientists need more proof to confirm that this is indeed an exoplanet. So, for now, it remains an open question. Interestingly, Kepler 70b isn't the only space body interacting so closely with its parent star. Another example is the exoplanet known as WASP-12b, located 870 light-years away. This giant planet has a radius nearly twice that of Jupiter and a mass 1.46 times that of Jupiter. It orbits very close to its host star, just 0.03 astronomical units away, which is why it experiences temperatures up to 2,200 degrees Celsius. Because of its proximity, the host star's strong gravity is slowly pulling WASP-12b in, and scientists predict that in about 10 million years, the planet will be destroyed. Given all these extreme conditions, it seems unlikely that scientists will prioritize exploring these kinds of exoplanets. They may seem unremarkable at first glance, but in reality, these worlds could have features that are more dangerous and extraordinary than we realize. When flying past the planet HD 189733b, it might seem like an ordinary, safe world at first glance, because it looks a lot like Earth. But if you were to get closer and enter its atmosphere, you'd quickly realize how dangerous it is. The planet's winds blow at frightening speeds, reaching up to 8,700 kilometers per hour, and they carry tiny pieces of silicate, essentially dust that could hurt anyone caught in it. As if that wasn't bad enough, the rains on this planet don't fall like normal water. Instead, they're made of molten glass, sharp burning droplets that would be deadly to anyone exposed to them. These extreme weather conditions happen because of the planet's intense heat and the strange makeup of its atmosphere. Speaking of its orbit, HD 189733b moves around its star in just 2.5 days, and it's likely tidally locked, meaning one side of the planet always faces the star while the other side is in constant darkness. To give an overview of the planet, HD 189733b is a large, bright blue gas giant orbiting an orange dwarf star in the constellation Vulpecula. It's located just 63 light-years away from Earth, not too far in the grand scheme of things. The planet is about 1.1 times the size of Jupiter and weighs 113% of its mass. Interestingly, HD 189733b orbits its star from only 5 million kilometers away, which is 30 times closer than Earth's distance from the Sun. This closeness causes the planet's surface temperature on the day side to reach a burning 930 degrees Celsius, while the night side stays hot at around 425 degrees Celsius. When HD 189733b was first discovered, scientists immediately began studying it, and in 2007, data from the Hubble Space Telescope revealed fascinating details about the planet's atmosphere. It turns out that the atmosphere is thick with a fog, and when the planet passes between the observer on Earth and its star, the fog causes the atmosphere to turn a reddish color. This strange hue may be due to particles like iron silicates and aluminum oxide floating in the air. Further studies also uncovered the presence of water vapor, neutral oxygen, and organic methane compounds in the atmosphere. Perhaps the most puzzling discovery was the unusual variety of methane found on the planet. This methane behaves differently than expected, glowing in a fluorescent state and giving off electromagnetic radiation in the infrared range. This suggests that there may be some mysterious activity happening in the planet's atmosphere, something scientists have yet to fully understand. HD 189733b is a prime example of how exploring planets with extreme environments can lead to surprising discoveries about the processes occurring there. The idea that there could be planets completely covered in water, also known as ocean worlds, started to take shape in the 1970s. Scientists discovered that a planet's internal radioactive decay and the tidal forces acting on it could melt water ice and create vast oceans beneath the surface. Similar processes are likely happening on some of Jupiter's and Saturn's moons. However, these moons remain frozen because they are too far from the Sun to receive enough heat to melt the thick ice that covers them. When we talk about an ocean planet, we're referring to a different kind of space object. In this case, the planet's oceans aren't hidden under ice. Instead, they are exposed on the surface. Additionally, these oceans are incredibly deep, often more than 100 kilometers deep. In 2004, French astrophysicists led by Christophe Sautin created theoretical models to study how such planets could form and evolve. Their theory suggests that if a planet's mass is more than 10 times the mass of Earth, it will start to attract hydrogen and helium from the gas and dust around it, eventually growing into a gas giant. On the other hand, if a planet has a mass between 6 and 8 times that of Earth, it will mostly consist of ice and rocks, with roughly equal amounts of each. To give you some perspective, all the water in Earth's oceans makes up only about 0.025% of the Earth's total mass. If a planet's orbit is far from its star, it will likely be either an ice giant or a cold super-Earth. In these cases, radioactive decay within the planet's core might melt some of the ice, creating a subsurface ocean. However, the outer layers of the planet will remain frozen. If a planet ends up in the habitable zone of its star, where conditions allow liquid water, its outer layers could melt and form a huge, endless ocean. Models suggest that a planet with a mass 6 to 8 times that of Earth could have a layer of water more than 100 kilometers thick. The enormous pressure of this water could reach up to 20,000 times the pressure of Earth's atmosphere, depending on things like temperature, impurities, and other factors. This pressure would be enough to create strange forms of ice, different from the water ice we know. Some of these ice types could stay solid even at high temperatures. For example, a type of ice called Ice 7 could form under these conditions, and it would be heavier than liquid water. The density of Ice 7 is thought to be around 1,650 kilograms per cubic meter, making it heavy enough to sink to the ocean's bottom, where it would form a thick ice layer, or cryosphere, that surrounds the planet's core. The chance to test these ideas came in 2009 when scientists discovered a small, dim star located 42 light-years away called Gliese 1214. This red dwarf star is much smaller than our Sun, with a diameter only 5 times smaller and a mass of just 15.7% of the Sun's. It's also 300 times dimmer, with a surface temperature of just 3,000 Kelvin, about 2,700 degrees Celsius, making it a typical, unremarkable red dwarf like many others in our galaxy. However, in the same year, astronomers found a planet orbiting Gliese 1214 called Gliese 1214b. This exoplanet is special, with a diameter 2.5 times that of Earth and a mass 6.5 times heavier. Simple calculations suggest that the gravity on its surface is only 91% as strong as Earth's. Gliese 1214b's average density is about 170 kilograms per cubic meter. This relatively low density suggests that the planet is mostly made of metals and rocks, similar to Earth. But interestingly, the density also suggests that about 75% of the planet's mass could be water or ice, with the remaining 25% being rock. This makes Gliese 1214b appear to be an ocean planet, with vast seas of water, or water-based ice. The planet orbits very close to its star, at an average distance of just 2 million kilometers, or 0.0014 astronomical units, which is 75 times smaller than the distance between Earth and the Sun. The orbit is also quite stretched, meaning that Gliese 1214b gets twice as close to its star at its closest point, perihelion, as it does at its farthest point, aphelion. The planet completes one full orbit around its star in about 36 hours. The red dwarf star Gliese 1214 is much dimmer than our Sun, about 300 times less bright. However, despite its faintness, the proximity of the planet Gliese 1214b to this star causes its climate to be incredibly hot. If the planet's surface reflects sunlight the same way Venus does, temperatures on Gliese 1214b would be around 393 Kelvin, or roughly 120 degrees Celsius. But if the surface is darker and absorbs more heat, the temperature could soar to 553 Kelvin, which is a scorching 280 degrees Celsius. One fascinating aspect of Gliese 1214b is that its orbit crosses in front of the star, allowing scientists to study its atmosphere using a technique called spectroscopy. However, the results so far have been unclear. If Gliese 1214b were an ocean planet, scientists would expect its atmosphere to be filled mostly with water vapor and some other gases. Yet, surprisingly, no traces of hydrogen, helium, or complex compounds like water, carbon dioxide, or ammonia have been detected in its spectrum. It's believed that the thick outer layer of the planet's atmosphere may be hiding its true composition. The conditions on the surface of Gliese 1214b are extreme, almost like being inside a massive steam boiler. The atmospheric pressure in the lower layers is at least 15 times greater than Earth's. The ocean and atmosphere are so tightly connected that it's hard to tell where one ends and the other begins. The water vapor near the ocean's surface is almost as dense as constantly boiling water. As you go deeper, the pressure increases, and by the time you reach 100 kilometers beneath the surface, the pressure is so intense that water can't remain liquid, even at such high temperatures. Instead, the bottom of the ocean is covered in dense, heavy ice, which is estimated to be more than 5,000 kilometers thick. Below this ice layer, there is likely a core made of rocks and metals. Sadly, the chances of life evolving on an ocean planet like Gliese 1214b are slim. Even if the surface temperatures were more favorable, the oceans of such planets usually lack the necessary microelements that are crucial for life. Even though meteorites bombard these planets from time to time, they don't bring enough chemical variety to spark life. Still, the study of ocean planets remains a fascinating pursuit for scientists. According to a 2020 estimate by NASA's mathematical models, there could be billions of planets like Gliese 1214b in our galaxy. Some might be cold, with oceans hidden beneath ice, while others could be warm, like this one. Since water is one of the most common complex chemicals in the universe, the search for ocean planets continues, offering hope for discoveries in the future. Far out in space, hundreds of light years away from Earth, there is a huge cloud, a vast unknown area where stars are born. This giant nebula contains many places where new stars are forming, hidden from our view. Some parts of this cosmic cloud are violently ripped apart by huge bursts of energy, while other sections are so filled with harmful radiation that they could destroy anything in their path. Among the swirling hot gases and fiery whirlpools of hydrogen, whole star systems can be swallowed up and lost forever. This place where stars are made is called the stellar nursery. Among the many star-making areas scattered throughout the galaxy, some are small and simple, while others stretch across huge distances, some even covering hundreds of light years. These nebulae are made of space gas and dust, slowly being crushed together by the strong pull of gravity. Most of these clouds are nearly invisible against the vast emptiness of space, but a few are bright enough to be seen from Earth with the naked eye. One such nebula is the famous Orion Nebula, which lies about 1,344 light-years from Earth. It's part of the Sword in the Orion constellation, a group of 3 stars that forms a clear, recognizable line in the night sky. The Orion Nebula stands out because it is not only huge, but also relatively close to Earth. Its size and closeness have made it an object of interest for scientists since the early days of astronomy. This giant nebula is one of the most studied objects in space, partly thanks to the Hubble Space Telescope, which took amazing pictures of it in 1993. These images showed the nebula's amazing range of colors, from deep reds to bright blues and purples. One especially strange feature was the bright green lines that appeared in some parts of the nebula. At first, scientists were confused, as the radiation causing this effect didn't match any known chemical elements at the time, leaving them to wonder what secrets this glowing cloud might still be hiding. At one point, scientists suggested an interesting idea: a mysterious element called nebulium, believed to not exist on Earth, but thought to be found in clouds in space. However, as science advanced, it was discovered that the strange light seen in these clouds came from a rare and charged form of oxygen. This discovery explained not only the unusual glow of nebulae, including our own Sun, but also helped us understand the vast and complex world of the Orion Nebula. Today, astronomers have found over 3,000 stars within this nebula, along with huge clouds of gas and many young stars, called protostars. These amazing space objects are all packed into a region about 23 light-years wide, interacting with each other in ways that are still being studied. The total mass of all the material in this region is around 10,000 times that of our Sun. If we take a closer look at the Orion Nebula, we can spot several different areas, each with its special features. One of the most noticeable parts is a group of stars called the trapezium, or Theta 1 Orionis. This open star group, which is about 300,000 years old, consists of 8 main stars, some of which are in pairs, while others stand alone. The brightest and most noticeable stars in the trapezium are 4 star systems, named using letters of the Latin alphabet. These stars are packed closely together within a region just about 1.5 light-years across. Each of these stars has a mass between 15 and 40 times that of our Sun, making them young and extremely hot. Among them, Theta 1 Orionis C stands out as the most massive and brightest star, not just in the trapezium, but in the entire nebula. This star is a white-blue giant with a mass of around 40 solar masses and a radius 8 times that of our Sun. Its surface temperature reaches around 45,000 degrees Kelvin, and it shines with a brightness about 250,000 times greater than our Sun. The strong radiation from Theta 1 Orionis C lights up almost the whole nebula around it, but there's little gas close by. This is because stars of this type often create powerful stellar winds that push material far away, scattering the gas into the surrounding space. If we travel a few light-years away from the trapezium, we'll find another interesting system, Theta 2 Orionis. This system consists of 3 stars held together by gravity, located near the Orion Bar, a huge feature of hot, glowing gas. For a long time, it was hard to study this area due to thick clouds of dust, but thanks to the James Webb Space Telescope, we've been able to capture more detailed images of this amazing region, showing the stunning complexity of the nebula. The first star in the Theta 2 Orionis system is a bit smaller and less bright than the biggest star in the trapezium, but it's still an impressive celestial object. Its surface temperature is about 35,000 degrees Kelvin. The second star in the system is much more massive, weighing 15 times the mass of our Sun, and it shines 12,000 times brighter. The third star is also massive, with a weight of 5 times that of the Sun, and its temperature is close to 14,000 Kelvin. But it wasn't just these bright stars that caught the scientists' attention. Using the James Webb Space Telescope's infrared cameras, they were able to spot hidden objects that were previously invisible, buried deep in the gas and dust clouds of the Orion Nebula. Thanks to this powerful technology, about 180 mysterious objects, known as protoplanetary disks, have been found at the center of the nebula. These are dense, dark disks of gas and dust that surround stars still in the process of forming. One of the most interesting discoveries is a star called Orion, which is only about 1 million years old. It's surrounded by a huge disk of gas and dust that stretches about 300 times the distance from Earth to the Sun. Because Orion is fairly close to Earth, scientists can study its structure and size in great detail. In just a few million years, it is expected to enter a stable phase known as the main sequence, and it will likely have a system of exoplanets and possibly moons orbiting it. The night sky of these future planets will be an amazing sight. Imagine a sky filled with a bright, multicolored glow from countless stars, much more numerous than what we see from Earth. From time to time, huge swirls of glowing gas would cover half the sky, turning the night into a glowing twilight. If we move further out to look at the larger region, we can see that most of the nebula is filled with scattered gas. The center of the cloud is made up of highly charged hydrogen, which absorbs high-energy radiation from nearby stars. The temperature of this gas can rise to around 10,000 degrees Kelvin in the heart of the nebula, but it cools quickly as we move toward the edges. The differences in temperature and pressure, along with the strong winds from stars, create huge currents and swirling whirlpools in space. These currents can reach speeds of up to 50 kilometers per second, and some of them are so big that they are larger than our entire solar system. In some parts of the nebula, long, thin